Welcome back. In our previous video, we built a complete PLC pulse-controlled servo positioning system and got our motor spinning smoothly in both directions. But in a real industrial environment, motion control isn't just about making things move. It's about controlling that movement safely and reliably. What happens when the machine reaches its physical end of travel, or when the drive throws an unexpected fault code? Today, in Part 2, we're addressing exactly that. We'll show you how to add position overtravel protection using 3 dedicated interposing relays. By the end, your system will be more robust, professional, and ready for demanding applications. For this upgrade, we'll use most of the same components from our previous build, plus a bit change in configuration. You'll need the same PLC with high-speed pulse outputs, the servo drive and servo motor from before, our trusty 3-button pendant station for motor control, and the S-on enable button. The key addition today is 3 interposing relays, which we'll designate as KA1 for CW limit, KA2 for CCW limit, and KA3 for alarm reset. All components are available from ATO. Links in the description. Let's understand the enhanced architecture. This remains a pulse and direction system at its core. The operator commands from the pendant are read by the PLC. The PLC's program generates pulse trains to the drive, commanding motor movement. The new elements are the 3 limit and alarm relays. When a limit is reached, the relay energizes, sending a signal back to the PLC to immediately stop pulse output, preventing mechanical damage. The alarm reset relay, KA3, allows the PLC to remotely clear drive faults after they've been diagnosed and resolved. Now let's look at the actual hardware layout. The 3-button pendant station is connected to the PLC input terminals, allowing the PLC to receive CW, CCW, and stop commands. Meanwhile, the S-on enable button is wired directly to terminal 7 of the servo drive signal connector CN3, enabling the servo system. Now we'll break down the wiring diagram into clear sections. The wiring for our buttons remains unchanged from Part 1. The 3-button pendant connects to PLC inputs, CW to X0.01, CCW to X0.03, stop to X0.05. The S-on button is wired directly to pin 7 of the servo drive's CN3 connector for direct hardware enable. Next, the diagram shows the PLC input and output terminal wiring. The PLC output port is responsible for sending pulse signals to the servo drive, which define the rotation direction and pulse frequency. Another important reference is the multi-core wire and plug number comparison table. It shows the signal cable wiring for the servo drive's CN3 connector. Each wire in the multi-core cable has a specific color, and each color corresponds to a specific signal pin and terminal number. By matching wire color, plug number, and function, you can correctly terminate each core wire on the proper screw terminal. The wiring diagram also shows the power and motor connections for the servo drive. As before, connect mains power to L1 and L2. Connect control power to L1C and L2C. Wire the motor's power leads to U, V, W, and GND. The signal connector CN3 carries pulse, direction, S-on, overtravel inputs, and alarm reset signals. The encoder cable connects to port CN4 to provide position feedback from the motor to the servo drive for closed-loop control. Finally, the diagram shows the wiring of the 3 interposing relays. These relays serve the following functions: KA1 for CW limit, KA2 for CCW limit, KA3 for alarm reset. When activated, the CW or CCW limit relay immediately interrupts motion in that direction, preventing further movement beyond the safe range. When KA3 is pulsed, it sends an alarm reset signal to the ALMRST input on the servo drive. With hardware complete, we configure the drive. First, initialize parameters. Press MSET, navigate to FN005, press data until PINIT appears. Press and hold MSET until DON-E confirms. Long press data to return. This step resets parameters to their factory defaults, preparing the drive for fresh configuration. Next, select the correct motor code. Navigate to parameter PN0A0. Long press data to enter motor code selection. Input your motor's code. For our incremental encoder motor, it's N.0007. Press MSET to confirm. Finally, set control mode. Navigate to PN000, which defines the control mode. Press and hold data to enter. Press data to move to the left digit. Set the value to 1, which represents position control mode. Press M-Set to confirm. Next, we program the PLC. Create a new project, select your device type. For us, it's CP1E. In device type settings, set CPU type to N40. Click OK. Now the PLC is configured for the CP1E N40 hardware. The program uses the SPED instruction, the speed output function. SPED is used to set the pulse output frequency and start pulse output without acceleration or deceleration. The ladder logic is structured as follows. Pressing CW starts sending pulses at 20,000 Hz for clockwise motion. Pressing CCW enables reverse rotation at the same pulse frequency. Pressing stop button stops the pulse output, and the servo motor comes to a stop. Now the new safety logic. If CW limit relay KA1 is activated, it immediately disables the CW rotation. If CCW limit relay KA2 is activated, it immediately disables the CCW motion. The alarm reset relay KA3 is controlled by a separate internal bit that we can trigger after fault diagnosis. Now let's see how the system behaves. Press the S-on button. The servo drive is ready to run the motor. Press CW and the motor rotates clockwise. As the mechanism approaches the CW physical limit, the CW limit relay KA1 is triggered, and the servo drive detects a positive overtravel condition, then displays fault code D00, and motion is stopped to protect the machine. This is where troubleshooting begins. According to the ATO servo drive manual, fault code D00 indicates position deviation excess. The position error has exceeded the allowable limit set in parameter PN5004. The manual lists the possible causes and recommended corrective actions as follows. Use this checklist from the manual to eliminate each possible cause. If the alarm persists after wiring and parameter checks, the servo unit may be faulty and needs replacement. Once the issue is resolved, the alarm can be reset in 2 ways. First, using the servo drive panel. Simultaneously press the up and down buttons on the panel operator to reset the alarm. Alternatively, you can cycle the control power, especially for those encoder-related alarms that may not be reset with the panel. Remember, always eliminate the cause before resetting an alarm. Resetting alarms without fixing the issue may cause equipment damage or fire. With this setup, you now have a more robust and safer servo position control system, capable of detecting overtravel, stopping motion in time, and properly clearing alarms when issues occur. If you'd like to build this exact system or adapt it to your own project, visit ATO.com to get all the components you need. From servo motors and drives to PLCs, relays, control buttons, and automation accessories, we have everything you need, backed by expert technical support and fast global shipping. Our products are widely used in industrial automation systems, CNC machines, robotics, motion control platforms, and smart manufacturing applications. You can find the product links in the video description below. Shop now at ATO.com. Did this guide help you solve a servo issue? If this helped, like the video and subscribe to ATO Automation. And feel free to leave a comment below if you have questions, run into issues in your own projects, or want us to cover a specific topic in our next video. Thanks for watching, and we'll see you until next time.